Hey, what are you doing?
I've got to film the wire rerouting video.
Why are we rerouting?
Yeah, wire rerouting.
No, why are we rerouting?
Yes, wire rerouting.
No. Why are we rerouting?
Oh, are you asking a question?
Yes.
Well, you're gonna have to watch this video to find out. What is up, my dudes and dudettes? Behind that camera is Colleen and I am Todd. And today we are inside of our 2022 Sprinter cargo van, and we're gonna be taking care of the old factory wiring harness. Mercedes actually routes all the wires for the rear signals, brakes, and camera outside of the walls here. And this can pose a bit of a challenge when we go to attach our own wall panels or build out our cabinets. So we're gonna bury this sucker in the wall instead. We have to drill some holes in the C pillar here, as well as one in the D pillar back there. I wish this was an option on the upfitters portal, because this is terrible, no cap Mercedes for real. But it's okay, we can solve our own problems around here, so let's go ahead and get to it. All right, so step number one is to remove these plastic bits. They come out pretty easy. You just kind of squeeze them and the tabs will come out of the respective holes. Go ahead and pull all this off. Erring on the side of caution, I'm gonna go ahead and disconnect the battery before I disconnect any of the rear connectors back there. I don't actually know if this is necessary, but I'd rather be safe than sorry. I just pulled the car in the driveway and we're gonna use the quick disconnect method. If you watched any of our other videos, you've probably seen this before, but we need to let the car sit for 20 minutes. So I'm gonna go ahead and set that timer now. Hey Siri, set a timer for 20 minutes.
I'm sorry, Todd. This video is great so far, but I don't think you need primer on trendy widgets.
Tim Apple is just trolling us now.
With the battery disconnected, I started removing the connectors for the taillights. It's 3 per side, 2 about waist height, and 1 down near the floor.
All right, friends, here's a quick Todd tip for you.
It's a Todd tip!
These lower connectors are an absolute pain in the keister to remove. They're actually plugged in about right here behind this wall cavity. So what you have to do is reach up in there in order to disconnect it. And obvi, my hands are way too fat for that. So I ended up using this pick tool. I'll link this in the description below, but I snaked it up in the cavity over the top clip, used that to depress that upper clip, while I came in with my bottom hand on the lower clip and it popped right out.
There's one more place you need to tackle on the rear end. Behind the dome light, there are 3 connectors itself included. The coaxial looking cable goes to the rear camera on our van, whereas the magenta plug is for the upper brake light. You have to reach pretty far in to get this one. And then the black one is for the LED light itself. Once everything is disconnected from the tail lights, again our van was 3 connectors per side, and the upper connections pull all those wires up and out of the wall cavities. And then, like the title for this step said, just start pulling off. I used a pick tool for most of it, but to be honest, it wasn't the right tool for the job, and it was a massive pain to get a lot of these clips out. In fact, if you look closely at my facial expressions for this section, there is some weird stuff going on as I try to make these clips my friend. What did you think I was gonna say? This is a family channel, folks. Fair warning, this light over the slider takes quite a bit of force. And last but not least, but still last, so probably actually least in this regard, is the factory grounding terminals. This is removed with a 13mm socket.
Now that this wiring harness has been removed, here comes the fun part. Not only do we have to document each individual connector and what it connected to, we have to document each individual wire and how it connects to its associated connector. The reason why we have to do this is because you can imagine if we had to drill a hole large enough for these connectors to fit through, there is no way we could do that inside of the wall in these pillars. So what we're going to do instead is pull out each individual wire, snake them through smaller holes in the pillars, and then on the other side, reconnect them to their associated connectors, connect those connectors to the associated components, and call this one done. Sounds simple, right?
Snap multiple pictures of everything, making sure it's clear what slot each wire color goes to.
Now that we've thoroughly documented each connector and the associated wire colors, we can remove each of these terminal pins. To help us out with that, we probably bought one of the largest terminal release tool pin kits you can buy on the online bookstore, but it was actually pretty cheap, and hopefully this has everything we need. Let's see if we can get it done.
Open the pin safety mechanism for each connector with a screwdriver. Look at this kit. Isn't it neat? Wouldn't you think my pin removal collection's complete? Wouldn't you think I have everything? Well, actually I do, but in reality you only need a few of these. For the larger connector, it's a number 5 from this kit. I'm not sure how to translate that to a different set, but you basically need it to go around the outside of the pin and push down the tabs on the top and bottom to remove them. So I learned this one the hard way. There are 2 different types of connectors on the tail lights here, the larger one on the left and the smaller one on the right. The larger one's pin locking mechanism actually opens all the way up on a hinge design, whereas the smaller one is designed to only unclip slightly. I was a bit overzealous on the other side and tried with all my might, so I might open up the small connector. Broken plastic was the specter, and it snapped like fingers at a poetry slam. So be careful with this one. For the white connector, I ended up using removal tools 21 and 22 from the kit. You really only need 21 to depress the pin's clips, but then you need to lever up the safety mechanism simultaneously. You can use a small screwdriver for this, but I've found the bent shape of 22 to be much more suited. Now it's time to drill the holes in both the C pillar and the D pillar. I brought a few tools along that are going to help us with this job. First up is a standard cordless drill. This is just your run-of-the-mill drill. Second is this right angle drill. This is a little bit more compact. The area where we're drilling is a little bit awkward, so I figured we might need to use this, but I'm not sure yet. For the actual hole, we're going to drill a pilot hole with this 1/4-inch cobalt drill bit. And then we'll use these aerospace hole saws. These are really cool. These are precision ground out of high-speed steel. And there's a little arbor that fits in that pilot hole that we drill. I was doing some test cuts on the panels that we cut out for the flare, and this thing cuts smooth as butter. I can't wait to see how it works on the actual pillars. Let's get drilling. According to your hole size, make sure you have enough room in all directions and mark the center location with a pen, followed by our good old buddy, the center punch. Next up is the pilot hole. In our case, it's 1/4-inch, sized perfectly for the hole saw arbor we are using. Also take note of the tape trap I've set up below the drill location. This helps contain the mess. Then I came in with the hole saw, applying light and even pressure during the entirety of the cut. These were way less grabbing than traditional hole saws and overall required a lot less torque. Here is that finished hole in the D pillar. We used a 1-inch hole saw, landing it between the 2nd and 3rd spot weld from the top. There's a nice hollow cavity back there that goes all the way to the van floor, so I was able to remove the metal scrap, no problemo. For the C pillar, you have to bore through 2 layers. I started from the front side of the van because it was easier to access, although much more constrained than the D pillar. Also, sorry about this terrible angle. Please enjoy this footage of the back of my head. For the back side of the C pillar, we did end up using the right angle drill, but we followed the exact same steps. We verified that we had enough clearance for our hole saw, we marked that position, we used the center punch, ran the pilot, and then finally made the cut. All right, folks, we made it through both layers of the C pillar. We are completely done drilling, and it's all thanks to the right angle drill. There is no way a regular drill would fit for this backside cut.
And although this arbor was a little bit short and I had to bend this tab during the drilling operation, there's no harm done. I just bent it right back into place. You might be able to drill completely from this front side, but that scares me because that second cut is completely blind and it is awfully close to the outside skin of the van. Do that at your own risk. Now, all we need to do, since all the holes are done, is we're gonna go ahead and deburr each of them, and then we're gonna put down a nice coat of our good old friend, the rust bullet. So let's go ahead and do that now.
After a quick deburr, we slap down the rust bullet on the exposed edges. Here's a peek-sees at the holes going through the C-pillar. That was a little bit too fast. Oh well, here it is going through the D-pillar. Damn, missed it again. Who is editing here? Oh wait, it's me. I'm the problem, it's me. Anyways, clean up all your metal shavings.
So I just got done putting on the rust bullet, and while I love this stuff, I did want you to be aware of something I encountered here. When I went to take off the lid, I pretty much had to destroy this thing. This is the last time I use it since the flare space video, and this just shows you how strong and how durable this paint actually is, that it literally created an adhesive seal between the lid and the container. What I'm gonna do in the future is probably just drill a hole and put a screw in there. It'll be much easier to break that adhesive seal on that screw with torsion rather than trying to pry this thing back up. I still really love this, but just wanted you to be aware of that if you're thinking about using this on your van as well.
Now that everything's prepped, it's time to route the wires. I didn't get good footage of this happening, so here's a later clip to show where I started. I chose to go through the B pillar as well. This part sucked. There's a pretty small slot and a contoured path you have to make it through. Obviously, it's possible, but you should really decide for yourself if it's worth the extra effort or not. It's pretty easy to hide this route going over this pillar instead. Now, before we go all hog wild tucking wires behind walls, we gotta think about the wire protection strategy. In our case, we went with grommets for each hole in the pillars. Remember, you may have to thread some of these on prior to moving on like I did here. This shot is dark, I know, but sometimes you have to sneak this stuff in when you can. Anywho, I felt the most natural place to run the wires was in the uppermost cavity crossing over the top of all the structural support members. By the way, get yourself a sweet headlamp if you don't already have one. So many handy uses for something that goes on your head. After everything was tucked in the wall, I started wrapping the harness in 1/2-inch split loom. When I made it to the first factory light that crosses the van over to the sliding door, I decided I wanted to keep it for the time being. I did have to cut back the tape a bit to free it from the harness. I also removed the connector so I could put some wire wrap on it as well. This particular type can fray on the end when cut, so here I'm using adhesive lined shrink tubing to prevent that. For routing this wire across the van, I snaked it up through this top square hole. Since this is above the roof support, it will be buried in the ceiling. They say a square peg can't fit in a round hole, but a round grommet fits in a square one no problem. Here I followed the previous factory routing. I've linked these replacement zip ties in the description below. Then I reattached the pins to the connector and simply plugged in and remounted the light. Boom shakalaka! Once everything was remounted, I tidied and tightened everything up across the support member using the zip ties. And well, you know we're a bit extra around here, so we also labeled the wire as well. Now that that lighting run was taken care of, I continued on with 1/2-inch split loom on the main harness. In the rear of the van where the wires drop down to the lights, they were already partially wrapped, but I fully wrapped them with 3/8-inch split loom and then covered the seam with adhesive back shrink tubing.
We have this factory wiring harness in the wall and it's completely wrapped with 1/2-inch split loom from up here behind the A pillar all the way to the back of the van. We're gonna go ahead and do one more thing. About every foot or so, we're gonna wrap a strip of Tessa tape around it. What is Tessa tape? Oh, I happen to have some right here. This is the same cloth tape that was used to wrap the wire harness in the first place. And the reason why we're doing this is because we do not want the split loom to open and we do not want those wires to come out.
I wrapped the split loom with Tessa tape about every foot, both on the main harness and the rear drops. Where the factory ground wires split out, I actually cut off a majority of the factory tape and reset the wire lengths according to how I wanted the ground in the wall. I held the rings together with a nut and bolt and then rewrapped the wires in Tessa tape. From there, I pulled the rear wires through the D-pillar hole and along the inside of the rear frame channels. There's pretty good access in all directions, and it's pretty obvious which way the wires should go based on their associated lengths. So, you remember those pictures we took earlier? Well, picture this. You trying to remember where each of these pins go without those pictures. This is important. Get the picture? And then we simply plugged everything back in. For the grounding stud, I decided to relocate this in the wall as well. I decided to use a Rivnut stud, and since I didn't have the tools to install them, well, I made one instead. This main part consists of an M12 nut that I bored out and faced, and a custom brass shoulder washer that not only protects the threads, but acts as a thrust bearing for the 5/16 inch nut that is threaded on top. What this allows us to do is hold the pressure steady on the Rivnut stud flange with a wrench on that larger nut while we slowly pull up the stud as we drive the 5/16 nut down with a socket. I did quite a few tests with this setup on some of the van panels we cut out for the flares, and it seemed to work great. I also checked ground with a multimeter on continuity mode through the panel, and it made me feel confident enough to proceed. But real quick, here's a short montage showing the actual fabrication of this part. Feel free to skip ahead if you don't like cool things. All right, this is getting a little bit ridiculous. This project may be way more effort than it's worth, but in order to relocate the grounding stud, we're gonna use this Rivnut stud, and I had to make that special tool, which was a lot of effort. And then when I went to check out to make sure everything fit, turns out a regular size wrench won't fit back there. So I also had to make a custom wrench, which is basically a socket that I chopped in half. I took this square tubing, I pounded it as flat as I could, and then I drove a 1-inch hole saw through it and then welded this sucker together. And then I wrapped the handle in friction tape just to make sure that it doesn't scratch or dent anything. I'm gonna go ahead and drill the hole through with this step drill bit all the way up to 1/2 inch, and then come and ream it out to the desired size of 17/32. Now it's important when you buy this drill bit, if you're gonna install Rivnuts or Riv studs of the 5/16 size, you want the one with a step down shank like this. This is a 1/2 inch shank on a 17/32 drill bit. That just makes sure that it can fit in your actual drill. I've gone ahead and linked the one I bought in the description below. I'm super nervous for this. I don't know why it's worse than the windows and the flares. So let's go ahead and see if we can make this happen. Here we are center punching our hole location as we always do, and then starting to drill the hole with a 1/2 inch stepped drill bit. So I ran out of shank length on the 1/2 inch step drill bit. So now I'm moving over to individual drill bits, and I'll just step up in a few increments. I was a little bit worried with this extra length that I'd drill through the back of the van on accident. If you've ever drilled through sheet metal, it can be quite grabby. So I've taken this old piece of PVC and I've just made a sleeve to prevent that from happening. I then increased the hole size in a few increments before putting the finishing touches on it with the 17/32 drill bit. This was sized for my particular Rivnut studs I bought. Then, doing my best to mark the flange size of the Rivnut around the hole, I knocked down the paint to bare metal with a Dremel for improved grounding.
All right, the moment of truth. We're gonna go ahead and install our Rivnut stud. The people on the Sprinter forum got me paranoid as HE double hockey sticks. This is a family channel. So I've got this LB8008. This is a copper doped anti-seize. This is going to go all around the base just to ensure a proper grounded connection. And then I have regular anti-seize. This is actually gonna go just on the threads here. Since my tool uses the threads to actually pull the Rivnut stud into place, I just wanna make sure that there's no galling taking place there. So let's go ahead and see how this all works out.
Here you can see I applied the copper anti-seize to the shank and the regular anti-seize to the threads. And then I pushed it into the hole we drilled earlier. There's a nice satisfying click as the Rivnut bottoms out.
Here goes nothing.
Driving the Rivnut stud takes quite a bit of force at first until it starts to deform. After that, it gets a little easier as the nut crushes onto the steel behind the wall. The custom wrench we made here worked like a dream, and overall this was pretty easy to install here.
All right, ideally I'd have a scope that I could look up behind here and check the back of the rivet stud, but I'm gonna go ahead and just measure and compare this to our practice ones. Should be a good enough indication that we did it correctly. And it is right on the money. I think we can call this one good. Let's go ahead and connect up these electrical connections and finish this project. Well, friends, that went about 1,000 times better than we could have expected, which is awesome. We're gonna go ahead and reinstall those factory terminals on that stud we just put in, but for the sake of going over the top, which seems to be a reoccurring theme with this channel, we CNC machined this copper toothed washer to go on first. This should help with grounding, and the idea for this came from a conversation I was having with some of the members on the Sprinter forum. If you're not a part of that and you're building a van, I highly recommend you check that out. It is a great resource. I thought this was a pretty good idea, and since we never machined copper, here is a montage of how we made this happen.
Once the washer was machined, I coated it with the same copper-doped anti-seize as before and installed the factory ring terminals on the stud with a 5/16 inch nut. I then used the multimeter to check the quality of the ground from my new stud to the previous factory stud. Beep beep baby, and you know we're good.
All right, let's go hop in the van to see if we've hooked up everything correctly. That's the brakes. Left signal, right signal, reverse. The camera came on, the touchscreen. I think we are Gucci.
I did one last thing before calling this one a wrap. Where the harness passes over each structural member, I added what's called an edge clip cable tie. These bite on the edge and give you a solid mounting point to firmly hold everything in place. This creates a super clean look and makes sure nothing is free to rattle around. P.S. These tapered flush cutters from Klein are straight bussin'. Well, that wraps up another episode of the Adventure Van Build Series. If you like what we're doing, go ahead and give us a thumbs up. It really helps us out. We think tucking the wiring harness inside the wall is going to make the interior and the panel build out that much simpler, and we'd love to hear if you share those same thoughts.
drop a comment in the comment section below if you have any questions or if anything in this video was unclear to you, and we'll do our best to help you out. And as always, on your way down there, don't forget to slap that subscribe button. Thanks for coming by. We'll see you next time. Are you asking your question? All right, let's hop in the car, the van.